Let us know how to calculate median for the group data. Before you have calculated median for the ungrouped data, where data are not arranged in a tabulation form, there is no frequency table, that is the raw data. Now, how can we calculate the median for the group data? Data will be tabulation from, and there will be frequency. One thing is most important to calculate the median for the group data is to identify the median class. This is a very important part. If you cannot correctly identify the median class, you cannot correctly calculate the median. So this is a very important part to calculate the median class before calculating the median. Here I give the step. First of all, if you have the total number of data n, you have to calculate n by 2. You will get some value. Second step, you have to calculate the cumulative frequency. I'll show you from the original data. Third step, from the cumulative frequency, you have to locate the value n by 2 point. Where it is located, n by 2 value from the cumulative frequency. That cumulative frequency, we can find the median class. This is the step, but when we'll go to the practical example, that will be more easier. So this is the formula to calculate the median. There are a lot of formulas. You can use any other formula. All the result will be more or less same, but you can use any other formula which is convenient to you. So if you like, you can follow this formula. So I will describe this formula. So this is the formula. L is the lower point or lower limit of the median class. So this is what I call you. First of all, you have to identify the median class accurately. Then n by 2 CF is the cumulative frequency of the median class. Before, we'll get more clear from the practical example. F is the frequency of the median class, and I is the class interval, class gap. What is the class distance? This is the formula. Step forward, you can use, again I am repeating, you can use any formula which is convenient to you. This is not mandatory to use this formula. So these are the data, income of the families in dollar. So as I told, first of all, you have to find the total number of family. If you sum up all the number of family, you will get n equal to 264. According to the first step, we have to calculate then we have to calculate the cumulative frequency. So how can we calculate the cumulative frequency? See, from the frequency, first one is 50, second one is this 50, you have to add the 54, you will get it 104. Again, this 85, you have to add with the 104, you will get it 189. Similarly, for this 45, you have to add 189, you will get it. If you better, you can equal sign. Same for all the same thing. And last one, 234, you have to add up 30. You will get it 264. So this is the way to calculate. You know already, but again, repetition is not bad. So this is the way you have to find the cumulative frequency. As I told, how can we identify the median class? N by 2, we have n equal to 264. If you divide by 2, n by 2 will be 132. Then I told, then from the cumulative frequency column, this is the cumulative frequency column, 50, 104, 189, 234, 264. This is the cumulative frequency column. What is the meaning of this? See, 50 mean family income 372, 380. How many family? There are 50 family. If you give the, because this data is in the ascending order, okay? 370, 380 up to 420. So data is ascending order. So if family income 370 to 380, how many family? 50 family. If you order 1 to 50 family, income is 370 to 380. And what is the meaning of 104? This means 50 family is finished. The family income 380 to 390. How many family there? The 51 to 104 family there. And third one is 390 to 40 is how many, which family? 105 to 104 is finished. 105 to 189 families. So these are the meaning of cumulative frequency. So let us find out the frequency, median class of the frequency. So n by 2, look at the in the cumulative frequency, or n by 2 132. If I go, where is the 132 number of family? Here is 1 to 50 number of family. Here is 51 to 104 family, and here is 105 to 189 number family. So our 132 is located in this value of cumulative frequency. This will be our median class. Again, I am repeating, we got 132. So we have to go to the cumulative frequency column, and where this 132 located in whose value? Inside the whose value, 50, it is up to 150 family, only 50 family, and 104 mean 51 to 104 family, and this means 105 to 189 family. Our 132th family, I can say 132th value. Okay, better value is 132th value. This will be the better. So 132th value. So our 132th value is here. What is this? This means 192 to 234th family. So our 132 is here, not here. It is not 1 to 234. This is 192 234th family. So our 132 will be here. So this is the median class. According to median formula, the L is the lower limit of the median class. So lower limit is here 339. So it will be here. N is the total of the frequency. We got it 264, and CF, as from the median formula, you know CF is the cumulative frequency before the median class. Here cumulative frequency 189, but before the median class, cumulative frequency is 104. This is the CF. Median class is here. For the median class, cumulative frequency 189. But according to formula that is developed after a lot of calculation, they found it. If you take the CF in the median class, you will not give the accurate answer. This is you have to take the before the median class. Always, please don't forget to take the cumulative frequency before the median class. So cumulative frequency before the median class, we got 104. Median class cumulative frequency 189, but we took it 104. Now, one question may arise: if our median class is the first one, if our median class is first one, suppose our median value is the first one, what will be the cumulative frequency before? There is no cumulative frequency before. One thing you have to say, statistically, when there is cumulative frequency, median class is the first one, statistically there is no median, but mathematically we have to take it before median class as a 0. So here, when the median class will be the first class, then the cumulative frequency before will be the 0. Just you follow in the will, and you calculate it. So let's go, and I is the class with the median class. Class with the 400 minus 390, you will get it 10. So this is the class with class gap of the median class, a class interval, and the remaining one is the frequency. What is the frequency of median class? Frequency of the median class is 85. See, all the values of the formula come from the median class. So this is very important to identify, locate the median class accurately. So putting all the values after doing the calculation, you will get it. The median income of the family is $393.3. So as I told, comment for the median group data, comment for the median ungrouped data, same. So this comment will be half or 50% of the family income is less than $393.3, or half of the family's income is more than $393.3. So this is the interpretation. 50% of the family income is less than 393.3, or 50% of the family income is more than $393.3. So this is the way to calculate the median. So let us do the second one. There is a other type of average or center tendency measure, that is called the mode. Mode, what is mode? Mode is the most common or most frequent value in the data set. That is the which number repetition is the most number of time, which value repetition is the most number of time. This is the mode. And mode is very useful for categorical data to calculate the measure of central value. So when mode, for interesting thing for the mode may be more than one. Remember, mean and median cannot be more than one value, but mode may be more than one. This is the thing, or sometimes it is called disadvantage of mode. When there is a one mode, this is called unimodal data. When there is two mode in the data, that is called bimodal. If you have the student score of the student 12, 15, 13, 18, 17, 20, 18, 19. Here 18 occur twice time. So maximum number of repetition is 2, which is 18, 18. So there is one mode 18. So this is the unimodal data. Bimodal data. So unimodal data are the common. So common for this. Comments, let us write the comment. So this will be the most of the students test score is 18, sorry, 18. Okay. And when there are more than one mode or two mode, that is called bimodal. If you see, this is the age of the student 17, 16, 17, 16, 18, and there is two value, 17 occur also twice, 18 also occur the twice. Sorry, 17 occurs 3 times, 18 also occurs 3 times. So there is mode 17 and 18. So there are two mode in the class. This is called bimodal. Also, you can write the comment if you want the comment. Most of the student is 17 or 18 years. Okay. So this is the bimodal data. When there is more than two, it is also called multimodal. Sometime in the data, there will be no mode. For the data 4, 5, 7, 10. So 4 occur only one time, 5 occur only one time, 7 occur only once time, 10. There is no repetition, so there is no mode. So in the data, sometime there will be no mode. So this is the limitation also of mode. There may be more than one mode, or there may be no mode in the data. Let us see the example. These are the student preference for the major in a university. Somebody want to take the business as a major, computer science as a major, simple computer science. Somebody want to take the networking. So if you do this data, and if you see what is the most number of the student preference, you will find, if you calculate, it is the networking. So same comment, most of the freshmen or student major is or preference is networking. This is simple comment. So only one is the most occurrence, that's the networking. This is the networking. So this is the age of the student again. If you, for the mode, there is no need to arrange the data in ascending order or descending order. So here, if you calculate the mode, the 17 occur the most number of times. So the most of the student age is 70. This is the mode. Now, how can we calculate the mode for the group data? So there is a formula. This is the formula. As like the median, you can use any formula if you want. So let us do the math. then it will be more clear. Practical example. These are the weights of the student, and this is the number of students. So weights from 49.5 to 54.5, and so on. And one thing I want to clear that this is the mean 49.5 to 54.5, but always in statistics we write like this, but this is less than 55.5. So here student weight is less than 55.5, and it is started from 54.5 to 59.5. This is meant this is less than 59.5. So this is upper limit, always less than, and it started from the lower limit same. This is always less than, okay? But we are writing the repetition 54.5, 54.5, 59.5, 55.5. But this is a less than, okay? Always remember less than, okay? I write for your convenience less than 54.5, okay? So this is less than from 59 to less than 55. This meaning if I write in the here 49 to 49.5 to, so this is the way to read the class interval. It is 49.5 to less than. A second one you can write it, so it will be more easier to you. This is will be 54.5 to 5 to less than 59.5. So this is the way to read the the class interval of the data. So where more like the media, first of all you have to find the most number of repetition. If you say most number of repetition of the data, I think 26. So this is the, if you see the if you go, so this is the thing. If we, I think it will be here. See, from the data or the table, we found that 64.5 to 69.5 has the maximum number of students, 36. So this will be our modal class. The median, it is called median class. For the mode, it is called modal class. So this is the modal class. First of all, you have to identify the modal class. That is the highest number of frequency, maximum number of repetition. That will be the modal class. So this is the formula. So as I told from the modal class, L is the lower limit. So L is the lower limit is 64.5. So it is 64.5. And F1 is the frequency of the median class. See, frequency of the median class is the 36, and F0 is the frequency before the modal class. So before the modal class is 29. So here, if you say, here if you identify, it is like, if you say like that, it is the F1. So if it is the F1, and before that, before F1, you know, F0, easy to remember, and after F1 will be F2. So all the value you get, and that is the one thing. Remember, here is the H is the class gap. Sometimes you can denote it by I. It doesn't matter. What is the class gap? If you do the class gap, you will get it 69.5 minus here. I think some something. I think class gap will be over here. That is the thing. So here is the formula. Lower limit is the 64.5. Frequency of the modal class is 36. F0 is the before 29, and F2 is the after. F1 is 25. And if you put all the value, and H or sometime I is the class interval, 69.5 minus 64.5, you will get it 5. So class interval is 5. If you put all the value in the formula, you will get it 66.5. kg. So the mode is 66.44 kg. And with the comment, these are the weight of the student. So this is the weight of the student from the we know from the data. So most of the student weight is 66.44 kg. So this is the comment or interpretation for the mode. One thing I want to share with you, there as we know, mode may be more than one. So ungroup data, we came to know for the group data, if it is more 36 is here, another 36 is here, so we have to calculate the mode twice. First of all, for the 30, if it is 36, first of all, you have to find the mode for this. Second one, you have to find the mode for this. So this is the point. When there is more than one maximum repetition, you have to calculate the mode more than one. Another thing, suppose our modal class is again the first one. So F1 is here, modal class. So F2 you go. What is the F0? F0 will be 0 here. Again, similarly, if our modal class is the last one, so you got the F1. So what is the F0? You got 13. What is the F2? Will be 0. So remember this. This is not so difficult. You already learned before. So this is the way to calculate the mode for the group data. One thing I want to share with you, when you have to use the mean, median, or mode. So they have different characteristics. Mean and median can use only numerical data, and the mode can be used for numeric and for the categorical data. But you cannot calculate the median, use the median or mode, median or mean for the categorical data. For the eye color, for the gender, you cannot use the mean or median, but you can use here mode. Another thing, mean is the most used method we can use, but one important disadvantage, it is extremely sensitive to the outlier. When there is outlier, some data is more extreme. Suppose age of the student 18, 17, some student in my master's class, unusual age, maybe 45, 55, some unusual data. Somebody normally weight is 55, 54, somebody have the unusual weight, maybe 120 kg. So when there is a extreme data, we cannot prefer the mean. So in that case, we have to prefer the median, because median consider on the medial value. So when there is sensitive outlier, you have to consider median. So I put all the thing in a tabulation form. For the categorical, nominal data, we have to prefer mode. Categorical, but ordinal data we can order. You have to calculate. This is categorical data. When you can order, you can do the median. When the numerical data, that is symmetric, there is no skew in the left or right side, you have to use the mean. But when they skewed on the right side or left side, left tail or right tail, you have to prefer. So this is the thing we have to remember before you have to use the calculation median, mode, or mode. That's all.